All right, let's dive into one of Python's most powerful, but, often misunderstood tools, the set. It is an absolute master of uniqueness, and by the end of this, you're going to see exactly why it deserves a spot in your coding toolkit. So picture this. You've got a list. Maybe it's a bunch of usernames or emails or even tags from a blog post, and it is a mess. It's just full of duplicates. Your job is to clean it up, to get a list with only the unique items. So what's the first thing that comes to mind? How would you tackle that? Well, if you're just starting out in Python, you probably reach for a loop, right? You'd make a new empty list. And then for every single name in your original list, you have to ask, hey, is this name already in my new clean list? If it's not, you add it. If it is, you skip it. And sure, it works. But it's exhausting, isn't it? It's this constant mental fatigue of asking that same question again and again and again. Have I seen this before? The whole process just feels clunky, maybe even a little error-prone. And you just get that feeling deep down that there has to be a better, more Pythonic way to do this. And you are absolutely right. There is. So, let's meet the hero of our story, the set. But wait, before we get into what a set is, we really need to clear up one of the most common points of confusion for anyone starting out with Python. This is super important. Okay, so here is the first potential trap for beginners. I call it the curly brace trap. See, both sets and dictionaries use these curly braces. Okay, so how in the world does Python know which one you mean? Well, it's actually pretty simple. It just looks inside the braces. If it sees just a bunch of values, like 1, 2, 3, it says, okay, that's a set. But if it sees key value pairs, like key, value, it knows you're making a dictionary. And here is the most important rule to burn into your memory. If you type just a pair of empty curly braces, Python will always default to creating an empty dictionary. So to create an empty set, you absolutely must use the set function. Honestly, just remembering that one little tip is going to save you so many headaches down the line. Okay, with that out of the way, what is a set? Well, think about the difference between a shopping list and, say, a security registry for a big event. On your shopping list, order kind of matters, right? And you might have duplicates, like 2 cartons of milk. A list is just like that shopping list. But a security registry, it has one job and one job only, to answer the question, is this person on the list, yes or no? It doesn't care if Alice signed up before Bob, and it definitely won't let Alice sign up twice. A set is a security registry. This right here is the core idea. Let that sink in for a second. A set's entire identity is built around this one single principle. It's not about the sequence. It's not about the position. It is purely 100% about existence. So now let's go back to our original problem, remember? Cleaning up that messy list of duplicate names. With this new understanding of what a set is all about, the solution becomes, well, it becomes incredibly simple. This is the aha moment. Just look at that. All that looping, all that checking we did before, it's gone. Replaced by one single, clean, readable line of code. You just pass your messy list to the set function, and boom. Python automatically takes care of the uniqueness. You no longer have to ask, have I seen this before? The set just does it for you. You know, a great way to visualize this is to think of that set function as a kind of funnel. You pour your messy list, duplicates and all, into the top, and what comes out the bottom is a clean, perfect, unique collection of items. It's really that simple. Now, there is one important thing you'll probably notice. When you convert a list to a set, the original order might change. But remember our security registry? Order doesn't matter. This isn't a bug. It's a feature. This is the set doing exactly what it was designed to do. So why do sets behave this way? Why can't you just treat them like a list? Well, it all comes down to their core design and understanding the trade-offs that give them all their power. This is exactly why trying to access an item by its position, like my set square 0, is gonna give you an error. A list is like a neat row of mailboxes, right? Each one has a number. But a set is more like a bag of items. You can reach in and pull things out, but it makes no sense to ask for the first item in the bag. There is no first. So this leads us to the big trade-off. With a set, you give up a fixed order and the ability to grab things by their index number. But what you get in return is immensely powerful. You get automatic uniqueness and a ridiculously fast way to check if something exists. So if you can't use an index, how do you even interact with a set? Well, the most common way is with the in keyword. This is what sets were born to do. They are totally optimized to answer that one question: is this item in the collection? As fast as humanly possible. The difference in feeling is huge. Checking for an item in a really long list feels like you're taking out a magnifying glass and scanning every single item, one by one, until you find it. But checking for that same item in a set, that feels like walking up to that security registry, stating a name, and getting an instant yes or no. It's that fast. But the power of sets doesn't even stop there at uniqueness and fast checks. Because they are designed from the ground up as these collections or groups of items, they are brilliant at performing operations between those groups. For example, you can merge two sets together to get all the unique items from both. That's called a union. Think of it like combining two different party guest lists into one master list. Or you can find just the items that appear in both sets. That's the intersection. That's like finding the people who are on both guest lists. You can also find the difference between sets, which is great for answering questions like, who is on guest list A, but is not on guest list B? Now, imagine trying to write that with loops and lists. It would be messy, right? It'd be error-prone. With sets, it's just a simple, single operation. Okay, so we know how powerful sets are, but it is just as important, if not more important, to know when they're the wrong tool for the job. Because using the right data structure is one of the biggest keys to writing good, clean code. So let's be super clear on this. 1. If the order of your items is critical to what you're doing, use a list, period. 2. If you need to link a key to a value, like a name and a phone number, you need a dictionary. That's its job. And finally, sets can only store immutable things, items that don't change. That's why you can put a string or a number in a set, but you can't put another list inside of a set. You can think of it like a simple decision tree. When you start writing new code, just ask yourself a couple of questions. First, does order matter? If the answer is yes, just start with a list. If no, then ask the next question. Do I need key value pairs? If yes, you need a dictionary. And if the answer to both is no, and all you care about is uniqueness and checking for existence, well, that is the perfect job for a set. So let's lock this in. It really all comes down to this one sentence. Use a set when you need unique values and fast membership checks, and you just don't care about order. The next time you're about to write a loop to remove duplicates, just stop for a second and ask yourself, is this a job for a set? And now you'll know the answer.